Hey guys, today we're learning lesson 3.2, multiplying decimals and whole numbers. So here's our key idea. When we're multiplying decimals by whole numbers, you do it much like regular long multiplication. But the difference is that the product, that means your answer, has the same number of decimal places that you multiplied by. Okay? So you're going to just multiply like normal, but then at the end, make sure you have the same amount of decimal places and you're good to go. So let's try an example. Find 15.8 times 4. We're going to line up the 15.8 and the 4. Now, normally it's best to put the number that has the most digits on the top when you're multiplying. Okay, so you're going to put the number that has the least amount of digits on the bottom. So that's why we're doing 15.8 times 4. You're going to multiply normally and get 63.2. If you don't quite know how we got 63.2, let me walk you through it. If you have 15.8 times 4, you're going to multiply the 8 times the 4 and get 32. Then you're going to multiply the 4 times the 5 and get 20. Add the 3 and get 23. Carry that 2. Then you multiply 4 times 1 and get 4. Add the 2 and get 6. And now we get 632. Oh, but wait a second. We have to have the same number of decimal places. So you have to count up, how many decimal places do I have? Oh, I only have 1. Now when I ask how many decimal places, I'm asking how many numbers do I have after my decimal point? I only have 1, which means I only need my decimal point there. That way I still only have 1 number after my decimal place. So it's going to be the same, okay? So you just have to count how many decimal places do I have in my problem and put that in your answer. So that's how we get the answer 63.2. Let's try another example. Here we're going to find 8.7 times 5. Now remember to line up your 8.7 and your 5 on the bottom because it's less digits. Multiply like you would normally multiply. Don't even worry about your decimal. We get a 5 here, carry the 3. 8 times 5 is 40 plus 3 is 43. Now we get 435. But you have to always go back and say, how many decimal places do I have? I have 1. So that means I need 1 in my answer. So that's exactly what I do. And my answer is 43.5, which you can see right here is what they get too. Okay? So we're going to count 1 decimal place from the right, and you get 43.5. All right? Let's do B. Again, we're going to just line it up, 0.91 times 6. Multiply like normal. 6 times 1 is 6. 6 times 9 is 54. Carry that 5. 6 times 0 is 0. Plus 5 is 5. I get 546. But we still have to count how many decimal places we have. 1, 2. I have 2 decimal places. So that means I'm going to move my decimal place from where it is here over twice. 1, 2. That makes my final answer 5.46. And that's my decimal. So that if you notice, that's exactly what they do here when they multiply and get 5.46 right here. Okay? Now let's briefly talk about these reasonables and estimates. Sometimes you can estimate your answer like they did here. They estimated 8.7 to 9 and 5, say 5, to see that our answer would be somewhere close to 45. So they got 43.5. Now if you forget to put your decimal in there, you get 435. You'd be like, wait a second, that's nothing close to my estimate. And that would remind you, oh wait, I forgot to put my decimal in there. Okay? Same thing with this next example over here. We round, keep the 6, but we round this to 1. So our answer is going to be close to 6. So if you forget your decimal, you can say, wait, 546 is not close to 6. You go, oh, that's right, I forgot my decimal. My answer is 5.46, which is close to 6. Okay? All right, here we go. Let's do another one. Find 3 times 0.016. We're still going to line it up, and we're still going to multiply like normal. 6 times 3 is 18, carry the 1. 3 times 1 is 3, plus 1 is 4. 3 times 0, 0. 3 times 0, 0. Do not forget those zeros, okay? Still multiply and put those zeros to the left of the 48 when you're multiplying, because we need to count our place values. We have 1, 2, 3 place values, which means I need to move my decimal 1, 2, 3. I need to put it right there so that my answer is correct, 0.048, okay? Now, sometimes when you're multiplying, you may not have enough decimal places in the product. So if you were going to stop short and just be 8, 4, because you know the rest are zeros, you may not have enough decimal places to count 3 to the left. 1, 2, 3. Oh no, I don't have any numbers. You can always insert 1 or more zeros in order to make your decimal right there, okay? So if you want to stop and you don't want to multiply zeros, that's fine. But sometimes it's helpful because the zeros probably need to be there anyway, okay? All right. Which expression is equivalent to 7 times n plus 0.0013? Notice that it's parentheses, so we're going to have to do the distributive property. So we're going to have to do 7 times n and then 7 times 0.0013. 7 times n is just 7n. 7 times 0.0013, that's something you'd actually have to figure out. So we can do 0.0013 times 7 and do normal multiplication and then just count your decimal places. 1, 2, 3, 4. So I'm going to go 1, 2, 3, 4. So my decimal is 0.0091. Now remember, these are not like terms, so you cannot put them together. You're done. That's the final answer. So then the answer is C, 7n plus 0.0091. Okay? One more example. Let's do a word problem. It says here, how high is a stack of 100 dimes? Well, in order to know how high 100 dimes are, first we need to know how high is 1 dime. Well, if you look at your picture, it tells you 1 dime is 1.35 millimeters. So we need to multiply that by 100 to figure out how high 100 dimes are. So multiply 1.35 by 100. If you do your normal multiplication, that's 135 times 100. Remember, you multiply this digit first, so we get 0, 0, 0. Then we have to move over one place and multiply this 0, 0, 0, 0. And then move over again and get 5, 3, 1. You're then going to just add it all up and get 0, 0, 5, 3, 1. But we had 2 decimal places, so I need to go 1, 2, and it's 135. So that's how they got their answer of 135 millimeters. But that's not the only method. Keep in mind, this is only one way to solve it. If you're multiplying by 100, you can just move your decimal over. So you are multiplying by a power of 10 because 10 times 10 is 100. So you can actually do this mentally. Since there are 2 zeros in 100, you can move your decimal point in 1.35 2 places to the right. So we can just move it over and get 135. Now some of you might be like, why to the right, Mrs. Vincent? Well, because if my decimal point is here and I'm multiplying by 100, my number is getting bigger. So that's why I need to move it to the right. If it was getting smaller, if I was dividing by 100, I'd go to the left. But I'm not. So that's why we went to the right. So that means a stack of 100 dimes is 135 millimeters high. And that's your answer. That is also the end of the lesson. So go ahead and try some problems and let me know if you have any questions.